Hello everyone, my name is Alan, and Brian and I are talking about the Rasa Contextual AI assistance. Okay, so first of all, what is Rasa? It is an open source machine learning framework to automate text and voice-based conversation. The company has been founded since 2016, so pretty much closing like 4 years old, and its headquarters are in Berlin. It's a German company and San Francisco in United States. And the founder is Alan Nicole and Alex Whitebowder. Yeah. So why do we use Rasa? Because in Rasa you can build the contextual assistant on Facebook, Slack, Google, WebEx Team, or Microsoft Bot framework, and some of them are like Rocket Chat and MetaMost and Telegram and quite little. So and also your own custom conversational channels. So basically, but most top five are very widely used, like Facebook, Slack, Google. Yeah, if you see the bot, say hello, and that's a part of chatbot. So what is a chatbot? It is a software application used to conduct an online that conversation via the text or text to speech and providing the direct contact with a live human agent. So here's a diagram mode, but about the chatbot, how they're working for it. Okay, so what is the conversational or contextual AI? First of all, they have a five topic. It's called it can talk, text and chat. It can learn and it can understand. It knows and it can contract. So it can talk in text and chat means a conversational AI should be available on voice like a Siri or text like a text message or on a web server. So later on, Brian will show the demo about how you can use chatbot um, building with the conversational AI or contextual AI. So it can learn means like it should be able to use a abundant history available from existing enterprise interact. Maybe later on we'll show the diagram because it's more deeper concept. So it can understand because beyond the chatbot capabilities, conversational AI should be understand complex sentence of human speech. For example, like why do I want to change the address? Maybe I will show it later on, and it knows by integration into your enterprise system because conversational AI should know who you are and it can transact. Conversational AI is a secure and can support enterprise security consideration. Well, this is more wordy um, explanation. Now there is a five level of conversational AI. So there are five levels because currently tomorrow Brian and I we have a conference on level 3. The last 10 years, the conversational AI is kind of just notification say, hey, you have a meeting tomorrow. And level 2 is a chatbot. And number 3 is contextual AI assistant, which is currently the company has already built on. And level 4 is a personalized assistant. In about, well, it says in about 2 or 5 years, it's like kind of their approximation. And level 5 is called autonomous organization. Okay, here's the Rasa open source. It can support multiple model like connector modules and natural language understanding and machine learning based dialogue management and response selection. Here's how it goes. It's say I want to change the address. Then the message connect with the connector modules, then transfer to the natural language understanding we call NLU and machine learning based dialogue management and response selection. Then send it back to connector module like live chat, app, or message. Then they'll pop up say, hey, what's your new address? For example, like I live in New York City, or you can change your address to Hoboken or any city you want. So NLU dialogue management is called, the goal of that is called the extract structural information from message. For example, like, okay, how much did I spend at Starbucks last week? So they have two names you need to understand. It's called intent and entities. I'll explain later on. So intents and entity, it means like intent is what user wants to achieve, and entity is kind of piece of information. For example, like how much did I spend at Starbucks last week? So how much did I spend is called the intent. So and Starbucks is kind of keywords. You also can change how much did I spend at Walmart last week. Anything you can change, just like keywords. You need to change. Like here's a pipeline, and then how the structure is like how much did I spend? They use the comma just like a Python uh like list, and then send to the text featureizer. They use a lot of bunch of numbers right over there, and then text featureizer they will send it to entity extractor and intent classifier. Just like in entity extractor means vendor name is called Starbucks, and intent classifier, for example, like search transactions. So the text representation, they do have two models. The first one is sequence model, and second one is non-sequence model. The first one it says have two important concepts. It's called one feature vector per token or words, and the feature vector for whole message. And the second one is called word order capture. The second one is called a non-sequence model. They also have two important concepts. It's called one feature vector per input, for example, the whole message, and orders of word not captured. Okay, here's the things that you need to know. It's called domain. It defines word of your assistant, what it knows, and what it can understand, what it can do. So here's another interesting example. It says intents. So intents in here we say what your bot can understand, same as entity. And the slot could be means what your bot can remember. What is your previous actions? Okay. Then actions means what your bot can do or what your bot can say. So responses, what your bot can say and display. And here's one. It's called section configuration. It's called the what your bot consider a new conversation. For example, if I type a text message to say want to change the topic, then we say Brian will be showed the demo right over there. Okay, here's the one. It's called the components. It is defined a user is processed what information to be extracted. So, for example, the language is called we call English, but they do have support different languages. And here's the pipeline. Pipeline here named convert, tokenizer, convert, featurizer, and regular expression featurizer. Those are components. So, okay. And here we need to know a little bit diet and diet classifier. So it is widely really used very often for using diet, even though there's another chatbot concept called BERT, but it's way more complicated than we put it in here. So the diet, it is now we are talking about how you're going to put a diet. Okay, it is used for intent classifier and entity extraction. So here's a diagram of right over there. Okay, so the second one is entity extraction. So possible approaches is a rule-based entity extraction and direct structure prediction of entity based on sentence context. So here's several. They have a pre-trained and a predefined rule-based model and train on your data and modify extraction entities. Here, yeah, another very important concept is called policy. So here, Brian, you can share the information about the policies.
Okay. So far, Alan has gone into intents, which are what the user would want to do, as well as entity extraction, which are like things that it can understand. So policies take that information as well as previous actions to determine what action the bot should take next. So each policy predicts an action with some sort of probability, which is called a core confidence. So could you go to the next slide? Uh-oh. Okay. So over here, this is kind of showing that. We have the user that wants to know how much they spent at Starbucks last week, which is taken in as the message in, and this message comes in through any sort of format such as Facebook Messenger, texting, or like services such as Telegram, WhatsApp, or Slack. This is then run through the natural language understanding pipeline, which then extracts which uses the whole tokenizer and goes through that pipeline and gets the entities and the intents, which is then fed into the tracker. The tracker also takes into account the previous action that the bot took. So for example, let's say the previous action was that the user said hello, and the bot said, hello, how can I help you? So then the user said, I want to know how much I spent at Starbucks. It then does the intent to entity extraction, feeds that into the tracker along with the previous action, and the policy will determine what action it should take next. So in this case, it determines that the user wants to know how much they spent at Starbucks. It'll take that action and send the message to the user. Next slide. Okay, so there's two different types of policies. One of them is rule-based. The other is machine learning-based. So you can use, it's recommended that you use both of those when you're building out your bot. And here are several of the rule-based policies. The first one is the memorization policy, where we memorize all the stories and make predictions based on the max history value. So think of a story as like a conversation that the bot should have. So like the user says hello, the bot says hello, then the user says goodbye, then the bot says goodbye. That's not a very interesting story, but that's just an example of like a story that you could feed into the bot so it knows how to respond to that. So the second one is the augmented memorization policy, which memorizes your stories but with a twist. So it does the same thing as the memorization policy, but it'll forget certain events until the match is found. If a match is found, until a match is found, if there's no match found. So it'll forget things that happened, I don't know, like let's say you're talking to it for like a full hour, and you asked it, oh, could you give me the weather a half hour ago? It may forget those kind of things until it gets a match. The next one is a form policy, which fills required slots and keeps asking for information until the slots are filled. So for example, if you're trying to ask the bot, could you transfer money? It needs to know what account type, such as checking or savings, how much you want to send and who you want to send it to, as well as a final confirmation. The next one is the mapping policy, where intents trigger actions. So these will execute regardless of context unless it's superseded by another policy. And we'll get into how exactly that supersede occurs in the next few slides. So like for example, like let's say you tell the bot call 911, it's going to drop everything and will do that action. So the next two are handling fallback, where it doesn't understand things. So for the first fallback policy is just failing gracefully. So if a model confidence is below a certain value, it's going to send a message saying, sorry, I don't understand you. So for example, if a user says blah, and the model obviously doesn't understand that, where blah is pronounced as BLKXYZ, it's going to say, I don't understand that. And the next one is a two-stage fallback policy, which fails a little bit more gracefully. So for example, let's say they say blah, and then the previous thing that the bot had, or the user had said, was filling out a form to try to figure out who to send money to. So it might say, oh, I don't understand that name. Could you give me a name that I understand to who to send it to? So in this example, the bot might have how much money you want to send and what account you want to take it out of. Next slide. So we have machine learning based policies as well, and this is where Rasa can use both machine learning and rule-based to generate decisions. So these policies should be used in conjunction with rule-based policies, and one of them is the Keras policy, which uses a standard long short-term memory, I think that is, to predict the next action. So. Mm-hmm. Oh, okay, great. So it'll try to learn the pattern of your stories, and so like for example, we know that when you're trying to fill out, make a balance transfer, you don't always say, oh, I want to send $50 to John from my checking account. You might say, I want to send $50 from my checking account to John. So that might be one way of trying to handle that. So it'll try to figure out the overall pattern of your stories, and It's good when your stories don't exactly match the training data, because obviously when you're training data, you can't account for all of the nuances of human conversation. And the next one is the TED policy, which uses attention to handle uncooperative dialogue. And it doesn't need as many story examples of uncooperative users. So if a user goes off on a tangent, like the user, like you've no doubt experienced this, where you've talked to somebody and you're like, I'm just trying to fill out this form. I just need to know, what's your name? Who do I send it to? How much money? And then they go off on a tangent telling you about the weather and their kids. And, my favorite car. I really do love the Toyota Corolla. So the bot will just remember all what it needs to, what it absolutely needs to know, and it'll just ignore chit chat. Believe next slide.
Okay.
So in the case where you have multiple policies, like as recommended by Rasa, if you have a machine learning and a rule-based, policies with higher confidence will win out. So if it says 75% possibility that it's a fallback, then that's going to win out over the memorization policy, as an example. So if confidence of two policies are equal, policies with the higher priority wins. So if they're both 33%, so if you have three policies all with 33%, then whichever one has higher priority is going to win out. So here, rule-based policies have higher priority than the machine learning-based policies. The reason for that is generally because rules are like strict rules, and like machine learning policies can be a bit fuzzy, as we know. So here we have form policy as being highest priority, followed by fallback, institute-stage fallback, then memorization, and augmented memorization, the mapping policy, and then finally the embedded policy and the keras policy are the lowest. And I believe that's my section. And Alan, I think it goes back to you.
Yeah. So for the conversational design, the real conversation are really complex. So basically, it's reliant on context. For example, say, how can I help you today? I just moved. But the bot will be responsive. What is your new address? To say, okay, it's a 120 King Street. But they'll ask you, what is the city you live in? You say New York City. For example, you can change like it's 11th Avenue, but the bot will confuse which 11th Avenue where you live in. They may ask you which city you live in. If you type New York City, they will simply send you maybe sometimes a wrong response, but say it's San Francisco. They will go to San Francisco. So that's how basically the conversational how to design it. So here's the important concept. It's called the mail to address. Okay, the previous action, they will ask you, say, shall we mail letters to the same address too? If you say yes, then we'll say response will be say yes. And say we are currently sending letters to some people's house. And also Rasa has provided dialogue handling. As Brian mentioned before, it says how much did I spend at Starbucks last week? And if you message in, they have an interpreter, they have tracking, they have a policy and action, and then message art is called you spend $12 at Starbucks. It could be says how did I spend at the Walmart? Then say okay, you spend $12 at Walmart. Yeah. So Rasa how they do in the demo. Brian will show how the training data goes. And machine learning models require training data that models can generalize form. For example, this is like intent bot challenge. Say, common example is say, are you a bot or am I talking to human? That's a very kind of important two common example they use. Are you human or am I talking to bot? Yeah. For example, okay, here's the interesting things. Intents, let's say I like food. I like apple. The apple could be means like in entity value, and your food is entity name. So okay, another example is called stories. Here, stories is not represent I tell the story for you. It's a kind of different words, even though it's kind of tricky because stories in English word it means very different meanings. Here in stories it means a representation of conversation between the user and AI assistants. And also stories are the form of training data for a dialogue management model. So for example, like how to get started, user type, say I'm the new user. And also if something does not match, we say there's a deny section. So author ask explain Rasa component, something like that. So here's the thing is called testing. Use the Rasa CLI to test your assistant. So later on, Brian will show the demo how to use this Rasa CLI. They have a three important concepts. It's called end-to-end evaluation, or it's called NLU evaluation and core evaluation. So end-to-end evaluation is called run through the text conversation to make sure that both NLU and core to make a correct prediction. For example, like stories, something like that. That's a correct predictions. Okay, so NLU evaluation, it will split the data into the test set or estimate how well your model generalizes and using cross-validation. For example, how score, probably like a machine model like 64% accuracy, which is not so good, but it could be underfitting or overfitting. That's later on. Brian will show the demo about that. And there's a called core evaluation. Evaluate your trained model on a test set, and a test story and generate a confusion matrix. Like for example, in the confusion matrix, it could be said you have a text negative or positive. That's a confusion matrix. You say, okay, if I predict someone win, actual result wins, that's a true positive. And also they have a true negative. Whoa. Yeah, something like that. Okay. And here's the next session. Brian will run a demo. So run a Rasa test locally when building the minimum viable assistant. This is kind of step Brian will show later. This is how you test your model after training and make a development more productive and reliable. Yeah, here's the demo section. Here's a very fun part.
Okay, I'm gonna try to take over. Let's see if this works. Let's just share the whole screen.
Real quick, do you wanna? Oh, okay, all good.
Okay, awesome. So, whoa, why can't I see? What is this? Sorry, I gotta clean up my browser a little bit. All right, so I'm going to be showing two things just to clarify. I'm going to just show the command line interface and how you would do things, but the focus on my section is going to be Rasa X, which allows you to not only use the command line interface to improve your bots, but also lets you use a web browser to share once you get a minimum viable assistant ready, you can share your bot out to the world, and you can continue to integrate it with using GitHub to allow for continuous integration and deployment of your bot. So this is my attempts at installing it locally. I'm using Windows 10. So over here, you would do, once you have everything installed, you would do Rasa train. You can see it's processing the stories, which were part of the bot. And I actually downloaded this from my own GitHub. I did git clone my repository, and then I did Rasa train, so it did it. And over here, it's going through the actions. So those are things that the bot can do. And it's going through all the trackers, and it went through 20 epochs. So the number of epochs it goes, I don't know if you can see epochs. Yeah, it's a little hard to see.
Actually, it's 23 epochs, I think.
Yeah, it went through 20. It went through 20 out of 20 epochs because we defined that in some files that I'll show later.
Mm-hmm.
And then it finished trading, it put the model somewhere, and it had several errors, but we'll be focusing more on Rasa X. So one of the cool things, like in addition to Rasa open source, that is way too small. Yeah. There's also this thing called, like I said, Rasa X, which allows you to integrate your bots, and how you would install. They have a one-line deploy script which works with Ubuntu 16.04 and 18.04. So you would load this up onto your machine, and you would use this command, which is curl-s get rasa x sudo bash in order to install Rasa on your server. So let me just show how to install it. So it's going to deploy it with using Kubernetes clusters, which is going to deploy all of your various services needed in order for Rasa to run. So as an example, you would need an action server, you would need a not necessarily a web server, you would need a bunch of different things in order to get Rasa X to work. So this will deploy all of that for you as a one-line deploy. So it's installing the Helm command line interface, and you're getting a welcome to Rasa X. It says it's being deployed onto your machine. And this line is something that you should do on a separate command line terminal. And this will allow kube control to get like all of your pods, all of the individual pods where your things are deployed. So it's currently being installed. It'll give you the password, which you can modify, as well as a database password where it stores some of its data, the Rabbit MQ, which I believe is the action server, as well as Redis, which is another sort of database thing. And it's deploying Rasa X, so I already have a machine set up somewhere else, so we're going to switch over to that. So this is on Ubuntu server. Can you see the bottom screen? Like where it says kube control? Let me clear it. So maybe
Yep,
make it a little easier.
I can see.
Let me move this. Okay, so on this machine, I've already installed Rasa and got it set up. So in order to get the status of the pods, they'll be installed on the Rasa namespace. So we would do kube control get pods, and we can see that it's running. So to use Rasa X and take full advantage of its features, we would go to our web browser, which is over here. You'll see that it's on one of my local machines. I'll also be showing one where I've deployed it to a Google Cloud Platform instance, and then I'll be sharing the link as well for that. So we have the password. We have to enter in the password, which I have modified to be AAA, not very secure. So once you start up Rasa X, this is what you'll see. You'll see this handy little icon, which will help you get set up. And welcome to Rasa X. You click Let's Do It. And this allows you to connect it to a Git repository. So in order to connect it to a Git repository, you would click here. You have to get the SSH URL for your repository. So I have one over here. This was actually the repository we worked on, Alan and I worked on during the certification class. So we'll have to clone it with SSH. And we enter in the target branch. So the benefit of having the target branch is we don't have to always use the master branch. You can use any of these branches you want. So I'm going to be using this one. Sandbox. And then we take this SSH key and we'll go ahead and add it to our file. We go over here, go into settings, deploy keys, add deploy key. Let's say Rasa Live. So you'll also want to allow write access because this will let you integrate any changes that occur on the Rasa X server into your actual Git repository. So we'll confirm and verify the connection. And that'll actually work. I'm going to skip over to, whoops. Oh, it actually looks like it'll work eventually. But let me go over to another machine I have set up where I've already set it up as well as trained a model. So in order to train your models, once you have, let me see if this one actually finished. That's still not doing it. All right, so we'll go over here. You click train, and then it would generate a model. So then you would select a model, you would make it active, and depending on your server, it may take a few minutes to actually generate. So I already have several models trained here, and this is the one that's active, but I can change those. Let me move this out of the way. I can make this one active, or I can make this one active, or I can just get rid of them entirely. So over here we have our training data, such as this is our natural language understanding data. So if it sees the sentence need to pay credit card, then it'll classify the intent as pay credit card. What's my Green card balance? Check credit card balance, check credit card balance. So this is just like all the different ways that it can see information. So who can I transfer money to, check recipients, etc. And so that's used for intent classification. You can also do regex lookups where you can set that up, as well as synonyms. So you could say Gringotts has one NLU example. Blah, blah, blah. So Gringotts has multiple different synonyms. So if it sees Gringotts with one T instead of two T's, it'll classify that as being Gringotts, as an example. And then it also shows you how many examples of this you have in your training data. So we have 3 NLU examples that incorporate the misspelling of Gringotts from the user. So next, we have responses. These are things that the bot can say. These aren't in forms or actions that it can take. These are just like things it can say. So if it utters account balance, your balance is currency in an account balance. Let me find one. So it'll say, would you like to schedule a payment of currency? So add continue. Would you like to continue? These are just things. When these things are called in the stories, or the bot decides that it'll do these things, these are the things that you'll see. And in the stories, this is where you define what action, like how to set up the bot. It's like training data for the bot to show it, this is what you should do when you see this. So the stars represent user information. The double sat hamburgers are greet paths. And the dash is what the bot will say. So if it sees the user saying a greet, then it will utter a greet. Same thing for goodbye. If it classifies as goodbye, it'll utter a goodbye. And if it sees to pay a credit card, so it'll say greet, utter greet, then it classifies that the user intends to pay a credit card. It'll load up the form, and then it'll close out the form. So, and then if you want to transfer money, the same thing. And this one's a little bit more interesting. So we have greet, we pay the credit card, we go through the form, the user says thank you, and then the bot says no worries. Now over here you can see the flow. So this helps you if you're more visual, you can kind of see like where your conversations will go, especially if you have multiple paths for your different conversations. So like the user can start with a greet, they can start with a no greet, things of that nature. And then we have our configuration file where we define our tokenizers, like how exactly we split up the sentences. We define our language, and we have our policies again. So we have the fallback policy, which we know is a rule-based policy. The threshold is going to be 75%. So anything below 75% confidence, it's going to say, I don't understand that. And we have augmented memorization, the form policy, so these are, and the TED policy, which has 20 epochs. So that's how many times it'll train. And the domain. So in this file, this is like again the world of our bot. We have our session, we have our intents. These are all the intents it can recognize, such as inform, the intent to pay a credit card, greet, goodbye. Entities, these are things that it can use to fill slots, like payment amount, credit card, payment date, a person. And then these are slots. So when it comes time to doing a form, like for example, like let's say I'm trying to pay somebody, I want to transfer money to somebody else, then that's a type of, that would use slots to try to fill out the information, such as checking account type, how much money, who the person is. So it'll use these slots to fill out those forms. And actions, responses, we saw those up here. Those are things that the bot can say. And actions are things that the bot can do. So it'll action account balance. It might make an API call or check the database to return information. So, or it'll utter OK. It might just say OK. Utter default is to say, sorry, I don't understand. Utter ask if payment form confirmed. So if you're trying to confirm a payment, you might say, OK, this is all the information I have. Do you want to continue? And etc. And finally, we have forms where we say, OK, this is our CC payment form, transfer form, transaction search form. And we also have our train, and if we train it, we get all of this. The other thing we can do is like we can like if it sees certain sentences during the conversations, then they'll show up in this inbox right here. You can see I have 40 NLU predictions. So I can tell it how it's doing line by line. Like, I want to do things. It identify that as pay credit card. I can say that that's correct. Or I can say abort as saying goodbye. I can say that's correct. And I want to send money, check recipient. Well, that might not be true. So maybe it should say it's transfer money. So you can see that it says 67% sure that you want to check recipients when really you want to transfer money maybe. So we can mark that as correct. And over here, we can see that this is part of that continuous integration and deployment pipeline. So we have added in new NLU data, I believe. Yeah, right here. So I want to send money, transfer money. So we've updated our model so we can add changes to the Git server. We can either commit them to the branch or we can make a new branch and then merge the changes. And let me just go ahead and do that. And that's going to take a little while. So this is one where I have, oh yeah, this is just a blank one as well, just to show you, okay, this is how it'll look. And I think this one, yes, whoops. I just closed it. 3. Okay, so here are the several of the conversations I have had with the bot, and also, so this is actually hosted on Google Cloud, so I can share out the link. I'll do that in a second. So you can do interactive learning with your bot, where there's 2 different ways you can talk to it. You can talk to it yourself, or you can share out a link to have people talk to it. So I can say, hello. It'll say, hi, how can I help you? And this is a custom thing that I did. So I went into the stories. During a greet, it'll utter a greet, and it'll utter a notice. And what's a notice? A notice is a response. Where's utter notice? I can't see it. Here we go. Okay, so I can do hello. So this is my attempt to try to help people out when they're talking to it. This way it knows what it can do. It's very limited because the action server isn't currently running, so it can't process forms correctly, but this is sufficient for the demo. So over here, you can see if you go into interactive learning, you can type out a message. Hello. So before you hit, like, you get a response from the bot, you can correct this behavior, and then it'll take the next action. So next action should be utter greet and action listen. So we can see the story over here. So it'll be a new story, greet, utter notice, greet, utter greet. So we can save that story as a brand new story, and it'll show up down here. So let me go and share this bot. So I'll call it live share and hello. For money. So you generate a link, you copy paste that out, and I just put it in the chat, so you can go and start talking to it if you so desire. But I believe that's about all I got. Oh, you can also change your password from here, as well as send support and feedback. Yeah, I think that's really about it. Oh, and then you can also filter out certain conversations and go through them and stuff.
Okay. All right. Sounds good.